Hello, Piper. This is the question 1 on your exercises. The service station owner sells good road tires. Ordered from a local tire distributor, and they receive from 2 plants. So the way I typically start these things is just put in the facts. So you've got plant A and you've got plant B. And then you're given that the service station receives an order from the distributor. There's a 50% chance that it came from plant A and a 50% chance that it came from plant B. So you know that's a given. So 0.5 there and 0.5 there. Now, and it keeps going. So I have already done all this, so I didn't want to repeat it. I just wanted to show you how I go about when I'm given information, I put it all into a logical format in Excel. So going on down, he knows that 20% of the tires from plant A are defective, so 0.2 there, and that 10% are the defective tires are from there. So let's forget sheet A for now and just go to question 1, which is basically the same thing. I just gussied it up a little bit, made it prettier. So delivery rate, or maybe rate's not the right word, but delivery location, and it is 50-50. So I did something a little different here. And note this formula. It's a good formula. So it is 1, the number 1, minus 1 times C5, or 1 times this, and that will always give you the inverse. So let's say the percentage was, let's say that they reduced it to 0.2 coming from plant A, then see plant B automatically jumps to the correct 0.8, because it has to be 1. Tire delivery, it's a whole, so it would be at least 1 tire delivered. And actually, technically, you can't get part of a tire from plant A and part of a tire from plant B. But of course, if you order 2, as I'm using here and on down, I'll show you. But the point being is that the calculation of the inverse is simply done as 1 minus 1 times the other one. And we have the defect rate at 20% and 10%, and this information was given in the problem. So later on I'm going to play with a hypothetical situation, but for now I'm using, you order 2 tires, and that's because it gets you the percentages. So going on down the contingency table, which is the upper part here of Bayes' rule or theorem, whatever you want to call it, is that you take the because I set it at the hypothetical number of tires is 2, then that means 1 tire came from plant A, 1 tire came from plant B. So that is simply the formula of the number of tires. Click here and see that highlighted. The number of tires times the percentage of the time the tires come from plant A And here too is the percentage of tires that come from plant B. So of course it's 1 and 1. And you go through you produce all the probabilities. So the problem you're given, the defect rate for plant A and B, is that, but we're wanting to base it now on the quantity of tires received. And again, just as a hypothetical, we order 2 tires so that the percentages would look the same. So this formula is the number of tires received times the defect rate. And this also is the number of tires received, 1, times the defect rate of 10%. And then again, I'm using the inverse of, well, what is the percent of non-defective tires? And I've got an extra space here. And that is 80%. And that makes sense. If 20% of the tires are defective, then 80% are not defective. And likewise, if 10% of the tires are defective, 90% are not defective. And these should total the number of tires. 1 is equal to 1 and 1 is equal to 1. Now, this is the total of not defective, and it is of the 2 tires. Again, it doesn't make sense with tires, but 1.7 of the 2 tires are not defective. It would make more sense temporarily. I'm just going to change this to 100 tires. And then this makes a little more sense. 80 of your order of 100 tires, 85 are not defective. 15 tires are defective. I'm going to change this back to 2 just to get it back to a percentage. So this is the upper part of Bayes' rule above the division sign that we're calculating. So we're calculating the probability, every probability, even though the problem is only asking for 1. This is going to give us the answer for all possible probabilities. So the next little table is to simply take the probability of not defective tires divided by the total not defective, E13. And then here, this is the total, down here. This is the total of defective tires, the 20%, divided by the total defective. And that gives you 67%. So, the question, using Bayes' rules, determine the posterior probability that a tire is from plant A, given that the owner finds that it is defective. And the answer is 67%. For a defective tire, the probability that it came from plant A is good, as you would imagine. It's 67% because it has more defects than plant B. Does that make sense? So you know it's going to be higher than 50%, but you don't know what that is without doing, you don't know that exact percent unless you use Bayes' rule. Well, it's 67%. Also, Bayes' rules then is also saying that, well, 47% of the time from Plant A, they're not defective. And 53% of the time from Plant B, they're not defective. And 33% of the time they are defective. So what this let's go back to real world for a second. Let's say it's 100 tires again. And you get 50 coming into Plant A and 50 come into Plant B. The probability that they are stays the same. However, in reality, what it's saying is that you're probably going to have 15 of the 100 tires defective, and you found one of those 15. Odds are 67% odds are that it came from Plant A. That's all it's saying. And, they always have to have it in a formula set up, like it's algebra or something, but, it really doesn't, this may be a good shortcut to remember it. I don't know. This is something you would do almost intuitively without even knowing what Bayes' rule is if you were in the real world. But anyway, that is the solution to question 1, and I'll send you this spreadsheet. Thank you. Have a nice day.